This is Adam Griffin with week 4, and this is my first video of the week. So this is problem 56, and the question is, if a car stops suddenly, you feel thrown forward. We'd like to understand what happens to the passengers as a car stops. Imagine yourself sitting on a very slippery bench inside a car, and this bench has no friction, no seat back, and there's nothing for you to hold on to. So first, for A, we have to draw a picture and identify all of the forces acting on you as the car travels at a perfectly steady speed on level ground. So our two forces are gravity and our normal force, which acts against gravity, keeping us up. And because we're moving at a constant speed, there's no friction, and there's also no sort of acceleration or any forces moving us side to side. So I'll switch to this so you can see the cursor better. So for part B, we're drawing a free body diagram, and if there is a net force, and just like I said before, there's no side-to-side forces, no friction or acceleration or deceleration, so the net force equals 0. So for part C, we're doing the same thing as for parts A and B, but now the car is slowing down. So since there's no friction, the only force that's acting on us is our inertia, so our motion going forward, because we're moving at a constant speed, and when the car slows down, we're still moving at that speed, but the bench is not stopping us because there's no friction. So we have our force diagram for that, which looks like this. All we have is our inertia, or the force of our motion, and no friction. So our net force is going to the left or towards the front of the car. And for parts D and E, we have to describe what happens to you as the car slows down and use Newton's law to explain why you seem to be thrown forward as the car stops. Is there really a force pushing you forward? So for part D, as the car slows down, your inertia continues to move you forward as there is no friction on the bench, and that is also the answer for part E. So the reason that you're thrown forward is because you're already moving, and when the car slows down, there is nothing slowing you down because you're inside of the car and there is no friction on the bench. So there is a force pushing you forward, and it's your motion or inertia. So for part F, we have to suppose that the bench is not slippery and that friction matters now. So you don't slide off, which means that friction is strong enough to keep you on the bench and is acting against your force of motion or your inertia. So the force responsible for your deceleration is friction, because it is equal to your force of motion, but in the opposite direction, because while you're sitting on the bench, as it decelerates and your inertia is acting on you towards the front of the car, your friction is pulling you towards the back, keeping you in the same place relative to the car. So this is what the force diagram looks like, and the net force is 0 because you're not sliding and you're not moving up or down. So that is the answer for all of the parts to 56, and thank you.